Hi all. Today we are going to discuss about random forest classifier. So first we have to install required libraries and we are going to use diabetes dataset. So basically the dataset has 15,000 rows and 10 columns. It includes features like glucose level, BMI, age and whether the patient is diabetic or not. So let's load the dataset and inspect it. So this is the data head, so different sample values and so on. So the diabetic column is going to be our target variable, where 1 indicates the patient is diabetic and 0 means they are not. So let's separate the features as X and the target as Y. So after separating the features, scaling the feature scaling is a crucial step, especially for machine learning algorithms sensitive to range of feature values. Uh, for this, we are going to use standard scalar to standardize the features. Next, we are going to split the data set into training and testing set. The training set contains 80% of the data while the test has remaining 20%. This ensures that the proportion of diabetic and non-diabetic cases remain consistent across both sets. So now that our data is ready, let's define and train a random boost classifier. This ensemble method uses multiple decision trees to make robust predictions. Here's how we can set it up. And the model is trained on the training data. Now let's make some predictions on both training and testing sets. So the first metric we evaluate is accuracy, which measures the proportion of correctly classified instances. So our random forest classifier achieves 96% training accuracy, while around 93% on test set. So this indicates strong performance with minimal overfitting. So a classification report provides a detailed breakdown of precision, recall, and F1 score for each class. So let's generate it for the test set. From the report, we observed that high precision and recall for both classes with an overall F1 score of 0.93. So actually the confusion matrix offers a visual representation of true positive, false positive, true negatives, and false negatives. So this is the plot of the confusion matrix. So therefore the diagonal elements represent correct predictions and the off-diagonal elements are misclassifications. Next, we evaluate the model's ability to distinguish between classes using receiver operating characteristics, in short form ROC curve, and its area under the curve, which is we in short term we call it as AUC, which in our case is 0.98. So our model demonstrates excellent discriminatory power with the AUC value being 0.98. The precision recall curve is particularly useful for imbalanced dataset. It shows the trade-off between precision and recall at different thresholds. So one of the strengths of random forest is its ability to calculate importance. So let's visualize which features contribute the most to the model's prediction. So here are the results based on the importance. We can see which feature is more contributing factor. So from this, basically we can identify the most influential predictors such as plasma glucose and BMI and age as well. So to further optimize our model, we use grid search to fine-tune hyperparameters like the number of trees, therefore n estimators, and trees depth, max depth, and minimum samples per split. So the fine-tune achieves a slightly improved accuracy and recall, solidifying its reliability. So coming to residual analysis. So the residual analysis helps us identify patterns in across errors made by the model. Finally, moving on to We have explored the power of random forest classifier from data pre-processing and training to evaluation and hyperparameter tuning. Thank you.